How small should a function be? Uncle Bob. Hello, I'm Chris Athanas. I'm a KMP developer. Tech support. They swear to God they're gonna come out on Tuesday and get that thing closed up. Finally, guys, they said they're coming out, so I believe them. Okay, today I'm gonna be responding to how small should a function be by Uncle Bob. Some of the stuff. Okay, so of all the people, these like software architect types, he's like one of the worst ones because he's giving the prescription that he's gone through the pachinko machine of thought process to come up with for a particular use case that's generally considered for what he's for what the IDE for the technology he was working on. But he doesn't give so. But other ones like Kevlin Henny, they give us the pachinko machine. He gives us the result of the pachinko machine. So just do this. It's like, and all these slightly spurgy, which I'm part of that group, slightly Aspergy, slightly autistic, which I'm in that group. People love to have just a quick, fast rule, just 5 easy steps. Just a one weird trick that will make their code base maintainable, understandable, readable, and fix all their development problems. So when he says this stuff, it's like, again, I believe it's sales driven now. I'm not shaming the game. This is just I get to expose it. This is part of my game, as I get to show the man behind the curtain. So a lot of these are coming from sales objections about managers, like how big should we? How much should I tell? Like he's giving these really not trite, but like overly unnuanced takes, and he says it with such Captain Kirk solidity. He just hand fists the thing, and gets people to believe that this is the way you do it. Software development. It's like, no, these are just. I wish he would say these are just suggestions. These are just ideas to think about. This is where he got this stuff from. He didn't make this up. There's just kind of ideas floating around that he glommed onto that he realized other people are interested as well. They have the question, how big should we make a function? Like, and so he's got, I have a solution for that. I'm going to put this in my presentation so people get this like ideas like, oh, wow, finally, we have some concrete things we should do with no nuance. No, it's like, just do this and you're good. And it's like, no, man, it's more, the whole thing's nuanced. All software development is trade-offs. And the trade-offs depend on all kinds of factors which are not logical. I know, we want them to be. We would so want them to be. Because it seems like they should be, because we're expressing these concepts in logic. So we think that, oh, okay, the whole thing's logic. It's like, no, it's not. It's not. It's this ontological, epistemological. What did I say? I was looking up these words today because I want to make sure I'm using them right. Yeah, ontological, nature of being. And yeah, the etymological, like the meanings of words. What these words are we sharing the same meaning? You'd be surprised. Most people are not sharing the same definitions of word. We call it the word definition problem. And the epistemological is like limits of knowledge. What is it possible to know? What is it possible to like? What is it possible that the source code is showing? It's not showing. It's showing our conceptualization of the problem space, so a machine can help calculate it, or store it, or retrieve it. All right, let's see what he has to say.
And I call this the first rule of functions. The first rule of functions. And I call this the first rule of functions.
I don't know why I did that.
The first rule of functions. First rule is that they should be small.
Okay, why? Why did they have to be small? Is it because he was working on an IDE that didn't allow the code to be twirled up, to be minified? So we wanted to have like an index and then have all the code someplace else? Is that the reason, Bob? Because we can twirl stuff up now. We can have all the stuff logically where it's supposed to be, but spatially we can have another view on it, which is the collapsed view. We can just collapse everything down. We can just look at the overview, and it should look like an index. It should read like how you want it to be, but instead of breaking everything up into 1,000 different pieces unnecessarily, it may make sense to do that, but don't do it prematurely just because it has to be small. What does that mean? And then smaller than that, what does that even mean? Why? Does he give a reason why these rules? He's given us he's already gone through the pachinko machine for his IDE, for his project, for his team, for his context. And the pachinko machine he's come up with, these are the output rules, and these are the things you're supposed to do now. He doesn't help us out like, why did you come up? Why these? Is it because the IDE is limiting and you don't want to have a big long listing and you don't have the collapse function at the IDE yet because this is the time when they're starting to put that stuff in there because they're realizing we don't need to put these in separate files. We can just have a different view on these things by collapsing around the curly cues. Come on.
The second rule is they should be smaller than that. I want to turn the knob up on this really high. I want the function small.
Why?
Really.
I want the function small. He's like a he's like a general getting ready to invade Europe. We're gonna invade Europe. We're gonna take this land back. We're gonna hit them low and hit them hard. I want the function small and smaller than that. It's like this guy. Let's keep going.
Small. How small should a function be? What's the paper size of the function? How many lines?
Whatever it takes to get it done, man. And if it's too complex to see every little piece of step, we break those off into conceptual steps. And then that may make sense to have that broken up that way. But maybe it doesn't. Maybe it makes sense to have the whole damn thing long. All right there. And have it bracketed in curly cues where you can clap stuff down. Maybe that's the better way of doing it. Instead of having to pass variables back and forth and doing these function calls back and forth, which could be turned into API calls back and forth. Maybe it makes sense to keep it all right there. Instead of having to break everything up. We don't have to break it all up. Maybe it makes sense. Maybe it makes sense to break it up. Let's not just say, just break it up. Like, no, you're doing that premature abstraction problem.
Should it be?
And making things more complicated because when you go debug it or read it or trying to understand, you have to go jumping around all over the place to a bunch of different files instead of just putting them in one place, which that's where they were logically anyway. And you're going to end up opening up these windows, which are going to show all the things side by side anyway, eventually. So why make the extra steps? Why, Bob? Why?
Does anybody remember when we first got screens? I mean, there was a time we didn't have screens.
See, he's remembering back here. This guy's like, oh, Jesus. This guy here's like, oh, Jesus. He's like taking a nap. Like, oh, man, Bob. Oh, man, Bob. With the function size again. But this guy's goofy as hell. These guys like, this is me. This is deep and meaningful. We're in the front row. We're paying close attention, and we're going to make all our functions super small. Why, Bob?
We wrote our code on paper.
Yes, we wrote our code. Yes, we should actually still write code on paper or paper-like substances. At some point, we're going to do a sketch. Maybe then we're going to transfer it to the machine when we're talking about it. But eventually, yeah, we're going to start off on a sketch on paper. I don't know who do people just preform in their brain, just slap it down? Well, that's not being helpful if we're going to be working with other people that need to kind of check off on the process. Is this really matching what how are the problem we're fixing? Maybe you can do it with one guy. More power to you if you can, but that's got a limited scaling factor. Let's keep going.
In the early days of programming, programmers did not know how to type.
What are you talking about? We did know how to type. What? No, he's going off in the weeds here.
We had no keyboard skills.
What are you talking about? They totally did. They were monsters. What?
Wrote the code in pencil, and we had other people enter it into punch.
Well, that was a phase of that, but we eventually got out of that and just had the machines where we'd have to punch the types right there. We punch our own damn cards. Yeah, that was a very brief moment when they did it in pencil and somebody else typed it in. That was like maybe a year. And then everybody's like, okay, we are sick of typing these people's programs. And you're like, he did an error and I made a mistake and you got this wrong. And, no, you just type it yourself, okay?
Cards for us. But then eventually we got screens. And
Yeah. It was way better because you're not using up reams and reams and reams of paper. Yeah, and you can see all things that you need on one thing. They've been doing the screens the whole time. I don't know why we kept paper for so damn long. I guess it was just cheaper. I don't know. It just they kept paper for way longer than necessary. Then my first computer, that PDP 8 or 10, in the Boston Children's Museum, the first computer I worked on, it was programming in BASIC. It was all printer based. I was like, this seems wasteful. They're like, you can take the printout with you. I'm like, okay.
We started typing ourselves. That was in the 80s.
Yeah, my next computer was this TRS-80. But I used all these. I'm very familiar with them. Yeah, there's a bunch of them. And it was a step up because the paper and the ink and everything got expensive after a while. So this was like way cheaper. Let's keep going.
And those screens, a typical screen was 24 lines by 72 columns. Why 72 columns? Yes, holes on the punch card. There were 80 columns on a punch card. The last 8 were sequence numbers, so we only needed 72 on the screen. That's the reason. and they were 72. And the rule...
Yeah, it was just the hardware limitation. Just people guessed there was all kinds of different ones out at the time, and that was the one they Schelling point. There was all kinds of cards, and but everyone Schelling pointed on this 80 column, 25 line deal.
About your function should fit on a screen. Well, that meant that the functions had to be about 20 lines of code. Is that the road size?
He's going to the hardware limitation of the IDE.
I have a better rule. A function should do one thing. A function should do one thing.
What does that mean, Bob?
That's the rule for how big a function should be. It should do one thing.
Okay, so then we're back to the whole thing again. Okay, so what are you talking about, man?
But now we need to define what one thing is.
Right, yeah.
What's one thing?
What is one thing, Bob?
A function does one thing if you cannot meaningfully extract another function from it.
Okay. Meaningfully? What does that mean? Meaningfully extract? See, this is again where the art comes in, the curation. Like, what is the meaning? Where do you stratify these things? How important is it to like make it super broken up? Is it really important to make it broken up? Is this really a key? What are we benefiting from here? So the code will fit on one screen back in the 90s before we had the twirling up. Let's keep going.
If a function contains code and you can extract another function from it, then very clearly that original function did more than one thing.
Oh my God, dude. Everything does more than one thing. Where does that line delineation? You're not helping us. He's like, he has something in his head, but he has no general rule because there is no general rule. This is one of those epistemological problems. This is one of those, the limits of knowledge. Because we don't know the problem space. That's where the humans are gonna have to keep making these decisions about what's important for what you're doing. So let's keep going.
Think from it. So I want all my functions to do one thing, and that means I must extract and extract and extract and extract until I cannot extract anymore.
Why? I've worked in these code bases before, and it's trying to find what's actually happening and what's working is so annoying and non-productive. So this is another way like this is so not useful way of doing things that like, but because the autists and the Spurs and the autists are like, ooh, I can do that. I can just extract 5,000 files. It's not helpful. I don't think it's helpful. This is a rule, But he never said, what's the benefit from doing that? To have a bunch of tiny little files all over the place? I mean, I've worked in these code bases. Like I said, it's like annoying. If you weren't the one that wrote it and was like, okay, I'm on board with Uncle Bob. We're going to make a billion functions about we're going to extract every meaningful level. Like, why though? I tried just to fit on the screen in the 90s. Okay, let's keep going.
I'm going to take all the functions in the system and explode them down into a tree of tiny little functions, optimally extracted.
Oh my God. See, this is why these code bases are open for complete, you can go direct at competition and not have these silly ideas about optimal extraction of functions. This is a way to make your code better. He's like, man, we'll make your code amazing. We have 1 billion functions. Are you serious? And no wonder people in these code bases, well, Uncle Bob said we would have. Where's the study that says this is study? Where's the study, Bob? Your study about this is the optimal way. And then also define what is the point of this? Okay, keep going.
Maximally extracted.
Maximally extracted. I want to see him hit him low, hit him hard. We're invading Europe, boys.
At this point, there are people in the room going, if I did that, I'd have thousands of little tiny functions. I would drown in a sea of tiny little functions.
Yeah, that's exactly what happens.
Not drown in a sea of tiny little functions.
Well, who says? Where's your software written this way? Where's your enterprise level solution written for real world problem, not a toy problem? Not this is how you do TDD. It's like no, not toy problems. Real things written this way that's been maintained, and the whole team's like, yes, this is the way to go. Like, show it. Not, all right, I'm not trying. I definitely did drown in tiny little functions, dude.
And there's a simple reason why you're not going to drown in a sea of little tiny functions.
All right, give me the reason, Bob.
You're going to have to give those functions names.
Oh my God, you would not believe how good people got at naming them, Bob. That is not the constraint, Bob. Holy shit. Bob, it's not the constraint, man. It's not the constraint, dude. We are really, really good at naming stuff. It was not, didn't hold us back, man. Where's your study?
You have to name those functions. And as you name them, you'll have to move them into appropriately named classes and appropriately named packages and appropriately named.
And that's what they did, dude. And for no apparent reason other than you're going to get to the Holy Land by doing this. Okay, keep
source
going.
files and modules, and you will create a tree.
Oh, by the way, I love Dev2's main simple. He's always got some source code thing he's working on here. Some this is like something's kind of sorting algorithms. Some kind of I don't know to do some sort of sorting object utilities. I was listening to is it Kotlin? I can't tell. Keep going.
A semantic tree of functions that you can follow by name. So you highlight that indent with your mouse and you invoke the extract method function of the IDE. And the IDE will come back with an error message and say, I can't extract it because it changes two variables. And I can't extract code that changes two variables. Well, what are you going to do now? Make them global. You think I'm joking, don't you? But now, look, you can extract that. And you can extract this one into another function. So now I've got two functions. I've extracted them out. I can take that one and extract it. Yeah. I can take that one and extract it. And I've got something very interesting here now. I have a set of functions, all of which manipulate a set of variables. What's it called when you have a set of functions that manipulate a set of variables? That's called a class.
Oh my god.
There was a class hiding inside this big function.
Or you could just make it a bunch of procedures. Why are you expecting all this stuff out? Why? Is there a particular reason why? Are these things that are used at other places? That's shared things. Just extract it out.
And if you think about it, of course there are classes that hide inside big functions, because big functions have a whole bunch of variables and a whole bunch.
That is not the reason why we have the classes and the variables. This is not the reason for this. Why are you doing this?
Of indents that manipulate those variables. So, of course, every large function is really a class with a bunch of little tiny functions inside it. And if you start extracting and extracting and extracting, you will begin to identify these classes that you would otherwise not have identified, and you'll be able to put them in appropriate names and spaces and allocate them nicely and partition your code. Wait, this is what.
How? What are you? What? This is the stuff that makes me crazy about Bob.
Start to extract and extract and extract. You find the true object-oriented structure of the system that you're trying to design.
That's not the reason for it, Bob. That is not the reason for the object-oriented structure. You need to go. Everyone needs to go look at Alan Kay. I've had in my course. I give it like a little primer on the difference between the COP stuff, which was Bob was talking about, class-oriented programming, and the object-oriented programming stuff that Alan back to object-oriented programming is called BOOP. That I call it BOOP. That Alan Kay was talking about, which is all about messages. And having APIs defined, which have messages between them, not breaking things down to a billion files. Like, where does he get this shit from? Bob, man. All right. If you want to let me keep ranting, want to give me a like and subscribe, and I'll talk to you soon.